Okay, welcome to today's lesson. In this video, we're going to look at separation techniques. So what is a separation technique, or what are separation techniques? Separation techniques, they are simply the various ways in which mixtures can be separated into their various constituents. Blood, for example, is an example of a mixture. It is made up of plasma, red blood cells, white blood cells, and platelets. So these constituents can be gotten. Blood can be separated into these various constituents, and that process is what we refer to as separation techniques. So the separation techniques, they are the various ways in which a mixture can be separated into its various constituents. So the first one we're going to look at here is filtration. And the principle is that it is based on the difference in particle size. Usually in filtration, what we deal with is liquid and solids. We deal with liquid and solid. So because of that difference in the size of the particle, filtration can work. So example of a filtration process is separating sand from water using filter paper. So in filtration, what we use is a filter paper. That filter paper will separate the solid from the liquid. So this is an example of filtration. Separating sand from water using filter paper is an example of filtration. Then we have sieving. Also, it is based on the difference in the size of the particle, just as in filtration, but here we're separating solid from solid. So because of the difference in the size of the particles, we can use a sieve. So example of a sieving process is separating iron filings from sand. Iron filing is a solid, sand is a solid. So why are we separating it, or how is it possible that we're separating it by filtration? It is because of the difference in the size of the particle. Iron filings should be smaller than sand. So if we use a sieve to sieve this mixture, we can actually separate the iron filings from the sand. Okay, another example of a separation technique is evaporation. And this is based on the difference in boiling point. It is based on the difference in boiling point. So an example of evaporation is obtaining salt from seawater by evaporating the water. So by boiling the water, by heating the water, we can get the salt from the water. As in, the water is going to evaporate. Water will evaporate, leaving the salt behind. Why is it so? Because water will boil at 100 degrees Celsius. Water will boil at 100 degrees Celsius and it will begin to evaporate. It will begin to disappear into the air while the salt will remain. So the principle of evaporation is based on the difference in boiling point. Salt will not boil at 100 degrees Celsius. Another example of a separation technique is distillation. Distillation is based on the differences in boiling point. An example of a distillation process is separating alcohol from water. So it is based on the difference in boiling point. For example, alcohol will boil at 78 degrees Celsius. Water will boil at 100 degrees Celsius. So there is a difference in their boiling point. So we can actually separate alcohol from water using this distillation process. Another example of a separation technique is fractional distillation, and this is based on the difference in boiling point of multiple components in a mixture. So in fractional distillation, just think of it this way, that there are many constituents in the mixture, there are many components in a mixture, and the difference in boiling point, the differences in the various boiling points is usually very close. So example of a fractional distillation is separation of petroleum into fractions like gasoline, like the diesel, petrol, kerosene. This process uses fractional distillation. And this is possible because of the closeness in their boiling point. So having known this, let's look at the sixth separation technique that we have here, which is centrifugation. Centrifugation is a separation technique and it acts based on the difference in the densities of components. It acts based on the difference in the densities of the components of the mixtures. So an example is separating cream from milk. Separating cream from milk. The major thing here is that centrifugation acts based on the difference in the densities of the components. One is heavier than the other. So separating cream from milk is an example, uses the process of centrifugation. Cream, for instance, is heavier than milk. And so, based on this difference in densities, they can be separated using centrifugation or using the centrifugating machine. The machine will work based on the principle of the difference in the densities of the component. Then we have another example, which is chromatography, and this is based in solubility and absorption property. It's based on the difference in solubility and absorption property of components on a stationary phase while moving with a mobile phase. It is based on the difference in solubility and absorption properties of the components on a stationary phase while moving in a mobile phase. An example of a chromatography process is separation of plant pigment or ink into their various components. For example, separating chlorophyll into its various constituents or into its various components. It uses the process of chromatography. And again, the principle is based on the difference in the solubility and absorption properties of components on a stationary phase while moving with a mobile phase. The next process we have here, separation technique, is decantation. And decantation is based on the difference in densities. Centrifugation is based on the differences in densities, but here we are using a centrifugatory machine. Here we are not using a centrifugatory machine. For example, separating oil from water. If you have a mixture of oil and water, just allow it to rest. The oil will come up, the oil will go up while the water will come down. Why? Because water is heavier than the oil. And so the water, which is more dense, it will come down, while the oil, which is lighter or is less dense, will go up. So this is an example of decantation. You leave the substance to rest. Based on the density, the heavier one will go down, while the lighter one will go up. In centrifugation, the principle is based on the differences in densities of the components. But what we use here is a centrifugatory machine. Here we don't use a machine in decantation. Another example of a centrifugation process is separation of blood into its constituents. It uses centrifugation. When you separate blood into its various components, white blood cell, red blood cell, platelets, and plasma, we use the process called centrifugation. Then another example of a separation technique that we have is magnetic separation. And this is based on magnetic property. Example is separation of iron filings from sand. So what we use here is a magnet. We use a magnet. So for example, if you have a mixture of iron filings and sand, you can separate them into their various constituents, or you can separate the iron filings from the sand using the magnet. And that is based on the magnetic properties of the iron filings. Another separation technique we have here is sedimentation, and this is based on the difference in density. For example, mud settling at the bottom of water is an example of sedimentation. So if you have a mixture of mud and water, just allow it to settle, the mud will go down while the water will be floating on the mud. So this is based on the difference in density. Mud is heavier than water, and so it will go down while the water will remain up. So this is an example of a sedimentation process. The 11th separation technique we have here is flotation, and this is based on the difference in buoyancy. For example, separation of wood chips from water. If you have wood chips that are dry and it's in water, just allow it to rest. The wood chips will float up because they are very buoyant. So that's flotation. The wood chip will go up while the water will remain down. And so you can easily separate the wood chips from the water. That's flotation. It's very easy. Then the last separation technique we're going to look at here is crystallization. And this is based on the difference in solubility. It's based on the difference in solubility. So a saturated solution is cooled to form a pure crystal of the solute. So in crystallization, the saturated solution will cool to form a pure crystal of the solute. An example is purification of sugar. Purification of sugar from a sugar solution. Purification of sugar from a sugar solution. That's an example of crystallization. So in another video, we'll look at these processes more in details and how they work. Thank you very much for listening.